Hello, welcome to our first day of trigonometry. I am really sad I'm not there today. You may have noticed some new topics on the warm-up, such as simplifying radicals, which may have been a while since you have simplified expressions like this. So we tend to, starting in chapter 5 and the study of trigonometry, we deal a lot with simplifying radicals, dividing. So just kind of putting these problems on warm-ups and refreshing your memory on how to deal with them, we do early on, so it doesn't seem like such a headache later on. Also, review of SOHCAHTOA. So let's see how you did on these. First of all, simplifying radicals in A. There are two different ways to do that. I'm going to work down below and see, just depending on how you learned from your teacher. I don't care how you simplify radicals. And 72 is kind of a hard one, so let me work with something easier like square root of 40. Okay. One method is to fully break it down into prime factorization. So remember, you can do 2 times 20, 2 times 10, 2 times 5. And remember, this is 2 times 2 times 2 times 5. Your teacher may have showed you to take out pairs of numbers because that's representing the square root of 4. So you can write it as 2 times the square root of 2 times 5, which is 10. So notice if you plug this into your calculator, as well as square root of 40, they should be equivalent decimals. Now, that's the longer way to do it, the prime factorization way, but some people really like to go about it that way. Now that you're in pre-cal, we're always looking for shortcuts, doing things a little faster. So I always ask my students, you're looking for the perfect square factor that's the largest, that divides evenly into 40. So when I say a perfect square factor, I mean 4, 9, 16, 25, so forth. Well, 4 is a perfect square and divides into 40. So I break this down into 4 and 10. Square root of 4 is 2. Square root of 10 doesn't simplify, so you leave it. Okay. So that comes in handy on actually A. This wasn't even the problem on your warm-up. Let's go over A, which was 72. Square root 72. Okay, so if you do this, the largest, or the easiest way, in my opinion, is looking for the largest perfect square factor that divides into this. So once again, 4, 9, 16, 25, 36, so forth. 9 does divide into it, but the biggest perfect square is 36. So if you notice that, 36 times 2, you can simplify right away as 6 square root 2. Okay, you can also do the long factor tree. This be a little bit more work on that. All right, so that was part A. B and C have to do with what's called rationalizing the denominator. So again, it's been a while since maybe you've seen this and worked with these, but we can't have a radical in the denominator. So we want to multiply by itself. And again, with fractions, you have to do the same thing top and bottom. So 1 times root 5 in the numerator becomes root 5. The denominator, root 5 times root 5 is root 25, which we usually skip because it becomes 5. Root 25 is 5. Now remember, you can't divide 5 into square root 5 because one's a radical, one's a whole number. Okay, on the next one, it's just a little bit more simplification necessary here. All I need to do is multiply by root 6, numerator and denominator. You could use 2 root 6, but it's unnecessary. We just need to get rid of that root 6. So the bottom, remember, these can multiply to be root 36 or 6, right? So you'll get 2 times 6 in the denominator, which is 12. The numerator is 3 times the square root of 12. So we have to do a lot of simplification on this, or a little bit. 3 over 12 simplifies to, like a fraction, 1/4. So I can simplify it as root 12 over 4. And the root 12 needs to simplify like we did in part A, which is 4 times 3, so we end up getting 2 root 3. And once again, I see a 2 over 4 here, which is just 1/2, right? So the simplified form would be √3/2. Okay. Now that one had a lot of steps. There were different ways to go about it. In the end, you should still have that same answer. Okay, so I hope that refreshed your memory on simplifying radicals. If not, we'll be going over them daily. Let's go over SOHCAHTOA. See if you guys remember that a little more. SOHCAHTOA. All right. So again, some of you are going to remember this pretty easily. Others, watch some instructional videos. Look it up on YouTube if you've forgotten this. In reference to 36, we've got our opposite over hypotenuse. So we're going to use sine on that. So we write our sine of 36 equals opposite over hypotenuse. Multiply by 10. So we have sine 10 times the sine of 36. Plug that into our calculator, and remember now in pre-calculus we have to have accuracy to 3 decimal points, either truncated or rounded. Okay, so that should be A. B is a reminder that when you're solving for an angle, we use the inverse button. So once again, figure out which trig ratio you're using. This is adjacent and hypotenuse, so we're going to use cosine of my angle is equal to adjacent over hypotenuse. So remember, plug into your calculator cosine inverse to find an angle. So remember how to use that on your calculator. Be familiar with it. So 56.251 degrees. So help each other out. Make sure you guys know how to use your calculators. Okay. And part C. This one is cosine again, so we'll have cosine of 18 equals 9.2 over x. You can multiply by x. And divide both sides by cosine of 18. Okay. So plugging that into your calculator, accuracy to 3 decimal places should be 9.673. I did forget to mention at the very beginning of this, be sure that you are in degree mode. Otherwise, you're going to be plugging these in and getting all of the incorrect answers. So the way you check if you're in degree mode is take tangent of 45 degrees. And you should get 1. If you're not getting 1, you're probably in radian mode, and make sure you go to mode, change it to degree. All right. Hope that was helpful. Nice little refresher of basic trig. And we'll be going over this again on some future warm-ups. All right.